evening and welcome to Tinkering with Edkelar. Last time I started to work on the HP 1600A logic analyzer, a valuable piece of digital history. Now let's see how it came to an end. The power indicator was an incandescent bulb, not an LED, but within the same clip case. Since it was burned out, I replaced it with an orange LED. No idea why they would have LEDs for most indicators and a bulb for power. And after the cleaning and recapping is done, assembly time! I managed to find the correct screw-in type caps for the rectifier board. Oof, expensive. This thing better work. add a dab of thermal paste between the case and the heatsink. This is the location of the 5-volt rectifier, so it can radiate out as good as possible. Wiring in the power switch again. A heat shrink? Oh well, just keep the paws away. Checking all the power rails. And yes, there's a CRT in here, so better make sure that the high voltage DC filter cap discharges before touching it. Regulator checkup is next. I don't want to fry any of the chips. I make sure that the rails are within specs before connecting them and readjust after the boards draw a load. The oxidized solder joints make it hard to get a reading at times, but eventually all the voltages check out. Next, the high voltage CRT driver section. And starting with the rest of the case too. And with the CRT shielding, it starts to look like a scope again. The assembly process is a bit like origami again. If you follow the correct sequence, it should be simple. If you mix up the steps, you will have to unwind and repeat. Quite the challenge, especially with the interwoven high voltage board and wires. Getting the front panel ready. I thought that I might be able to insert the tube through the front panel opening, but nope, still no. So off with the case, tube in, case on. Adding the bezel assembly and the blue filter. Reconnecting the deflection and grid connections. Again, too tight for fingers, nerve-wracking with pliers. And now all the logic boards, starting with the backplane. The front PNC connectors are next in sequence. No access to the nuts with the main PCB in place. The trigger bus connector is a bit weird. It is a 2-pin BNC, but a smaller diameter and 3 locking tabs on the outside. Anybody out there who knows where I might get a cable for that? The main CRT driver board is next, but routing the ribbon cables between them is an art form in itself. And the main PCB, including the ribbon cables that connect to the trigger switches and trigger delay. Final touches on the case, including the high voltage protection cover, and of course the handle with shiny buffed up springs. And after finishing all the little trim pieces on the front panel, I can clean up a set of probe pods that I found. Without those, the device is not much use at all. Compared to the later model, these are built with discrete logic still. No hybrid chips. Some of the glue residue was really caked on and required some scraping. But since the probes already had some cosmetic damage, I thought it couldn't get any worse. They seem to have been made in two different versions. one with spring-loaded contacts for the probes and ones that have screw-in connections. The clock pot I got has one, the logic pods the other type. Humph! But at least they should work. And here we go! In regular mode or table mode, we can see the 16 bits on the left as they arrive. The trigger offset is highlighted as a brighter row. This is the A side. On the right hand side there is another set of values called B. There is a Store A to B button that transfers the current values to the B side, so you can highlight the differences between the two or even trigger on the A is not equal to B condition. In map mode, the 16 bits are shown as a grid of 256 by 256 positions, indicated by the marks on the screen. So every value has one position on the screen. The idea is that a functioning device will paint a certain pattern on the screen. That is, when you hook up the 16 bits to the address bus of a device, it should paint a distinctive pattern depending on how much activity is in what parts of the address space. This should make it simpler for service people to see misbehaving computer code bases as a simple image. The map can be zoomed in because the normal view there are only 6 upper bits shown. To zoom into one of the 4 quadrants, you can select the zoom mode. The problem was that the map mode didn't behave at all. The values were all over the place and the cursor, the 0 that was supposed to indicate what quadrant to zoom into, was also off. Likewise, the display was fuzzy at times for no obvious reasons. Lots of tracing signals and troubleshooting later, I found out that the 4 multiplexer chips and the comparator that are handling the screen coordinate system and the cursor goes here decoding were faulty. Chips U35 to U38 and U40. They didn't produce proper TTL outputs anymore. One of the faulty logic chips just fell apart when I tried to desolder it. It might have had a crack before. And after changing them, no dice still. But the reason was slightly more obvious this time. The originals were 74C157 chips, while I could only get my paws on 74LS157 on short notice. The logic levels are not quite compatible, so I had to botch in a few pull-up resistors on the inputs. That did the trick. And because the signals would oscillate, the screen display was trying to show hundreds of cursors at the same time, hence the fuzziness. Oh, and if you don't need all the 16 bits, you can mask out the rightmost ones with the column blackout potentiometer. Looking into the service manual, I found the part number of the missing accessory bag. Funny enough, a surplus seller in the US had 2 of them on stock. Well, I just need one. I had to recut the threads in the case though. Metric Cat here doesn't stock well with imperial-sized screws. And that's it for this episode. I hope you enjoyed this vintage test gear. Did I mention that it connects with a sister model? I wonder if I could find that somewhere. Oh, someday for sure. See you next time. But eventually all the voltages check out. But they can never leave.